Here's an example on how to conduct a significance test. So this is a situation where we're given some information. We know that the old screening method misses 15% of the cancers, and these researchers hopefully to improve on that. So they conducted a random sample, which is important. We have random samples. We can use inference techniques. They said there were 70 women, and they missed 6 cancers. Okay, so that's the data from the sample, and we're going to try to compare that to this old method failure rate of 15% and see if something more than chance random variation is at work here. Okay, and then they give us this alpha level, and we'll talk about that in a minute. So as Dr. Ambele mentioned in the video, there's some steps. I mean, it's pretty much a recipe, a cookbook recipe on how to conduct a significance test. And the first thing you want to do is establish your hypotheses. Then we're going to calculate a test statistic, find the p-value, how likely is it of happening, of just chances at work, and then we make a decision. Okay, so let's get on with this next part. So what we want to prove or disprove is that this 15%, hopefully, if the researchers want to show that this new method misses fewer cancers. So that's what we got to show. And what we're going to do is we're going to relate our two hypotheses back. We're assuming that the 15% is true, and we're going to try to show that it's not. So here's a set of shortcut formulas I pulled together for us. There's different textbooks use different things. Typically they'll use mu for means, and different books use theta. The Moore book where I'm using this semester uses p. So it doesn't really matter. These are proportions, okay? And what I do want you to notice here, though, is that HO in both cases, whether you're working with means or proportions, it's always equals. So with the HO, the null hypothesis, is always that the proportion or the mean is equal to that old value. In this case, it was the 15% missed cancers, right? So what we'll do is we'll write a HO value, because this is dealing with proportions, and I'm going to use p since that's what the Moore book is using. So we're going to say that p equals 0.15, or that this tells me that the new test isn't any more effective. It's missing about the same rate of cancers as the old method, and the only reason it's different is due to chance random variation. Okay, so now what we're trying to disprove, or we're trying to prove that the HO value is wrong. So what we're going to say is we're trying to say that it misses fewer than 15% of the cancers. So I'm going to use the less than. If somewhere in the problem, and I'll do an example later where it talks about greater than, then we'll use the greater than, or a two-tailed test. We'll talk about that too. So these are the two hypotheses for this situation. Remember, HO is always equals. HA will be one of these three choices: less than, greater than, or not equal to. Okay, I'm going to have you try have you try an example and see if you can make this work.